Hello, this is Dr. Mears. Today we are going to be going over paper 1 example number 15. So paper 1 has 15 examples, and so this is going to be the last one for our schemas. We're going to be going over to paper 2 examples for our schemas now, and those videos will be up shortly. So let's finish off with paper 1 example 15. This is about a cuboid. This has a little bit of geometry and some of calculus in it. So let's go. A cuboid has a rectangular base of width x centimeters and length 2x centimeters. The height of the cuboid is h centimeters. The total length of the edges of the cuboid is 72 centimeters. And so they gave you a nice diagram. They told you it's not drawn to scale. They told you that the width was x, the length was 2x, and the height was h. Let's see what they want us to find. The volume V of the cuboid can be expressed as V equals A times x squared minus 6 times x cubed. Part A, find the value of A. So here's the thing, here's the volume. They don't tell us what the volume is. They give us no volume. If I look back here, the information that they do give us is a total length of edges. And total length of edges is telling me that it's the perimeter. And the perimeter is going to be equal to 72. So we're going to have to use that information in order to transfer from perimeter over to volume. Now, how do we do that? Well, using the perimeter is the total length of all the edges. So for part A, perimeter equals total length of edges. We know that because it's 72, so they gave us that. Now, let's actually go through and write out all of our edges and let's add it up. So I am going to actually extend this so that we see the back of the diagram. So I drew those 3 lines in. I need to get all of the edges here. So they told us that this is the height. So back here is a height, this is a height, and this is a height. So how many heights do we have? We have h plus h plus h plus h. So that is going to be 4. We'll simplify in a minute. Okay. Next, let's look at the widths that we have. We have x here. There's one here, one here, one here, and one here. So we have 1, 2. Oh, I'm sorry. This is not. My bad. That's going to be a 2x. I'm sorry. So we have 1 here, width, 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 and width. So we have plus x, plus x, plus x, plus x. And then, as I was jumping to it, here's the length 2x, here's a 2x, and here's a 2x. So we have 4 of those, 4 2x's. And now let's simplify. Let's combine our like terms. So we have 72 equals, we have 4 h's, 1, 2, 3, 4, plus we have 1, 2, 3, 4 x's, plus we have 2, 4, 6, 8 more x's. We can combine these are like terms, so we're now at 72 equals 4h plus 12x. Now at this point I need to explain to you, we have a nice equation. And what our equation is going to help us do is get the height in terms of the variable x. So if you notice the width, w, they wrote as the variable x. They wrote the length in the variable x, 2x. So we need to find what our height is in the variable x. And so we just made a nice equation where we can solve for h so that we can find what the height is in terms of x. So I'm going to subtract 12x from both sides here. I cannot combine these because they are not like terms. 72 does not have a x next to it. So it's just 72 minus 12x equals 4h. The 4 is linked to the h by multiplication, so in order to undo the multiplication, I'm going to divide. When I divide, I must divide both of these by 4. 72 divided by 4 is going to be 30. Oops, my bad, I'm sorry. 72 divided by 4 is going to be 18, jumping ahead. And negative 12x divided by 4 is going to be negative 3x. So that equals the height in terms of x. So up here, the height is really 18 minus 3x. So we have each of the dimensions in terms of one variable, and that variable is the variable x. So using that, what I am going to do is I see that we have height, I see that we have length, I see that we have width. And in order to find the volume, you multiply those three together. So you know what? I want to find out what my volume is going to be. I know they gave us a formula up here, but it doesn't really help us with anything. So I'm going to find what our volume would be in terms using now my x for my height. So volume equals length times width times height. So for our volume, our length was 2x, our width was x, and times our height was 18 minus 3x. And I'm going to simplify this side of our equation. So v equals, this is really a 1, so 2 times 1 is 2, x times x is x squared, times 18 minus 3x. Now I have multiplication here, I have parentheses. I am going to get rid of those parentheses by distributing the 2x squared. So v equals 2 times 18 is going to be, there's my 36x squared, 2x squared times negative 3x, 2 times negative 3 is negative 6, x squared, this is really x to the first, we add the exponents, x to the third. Oh my, this totally reminds me of something I've seen before. There was this actual part of the equation that reminded me that I've seen this up here. Up here it said volume equals A times x squared minus, and the net minus 6x to the third. So this part reminded me I've seen it somewhere, so I just rewrote this equation right underneath this one, and guess what? I can just match this up. Guess what my A is? My A is 36. Yay! So I'm going to write down A equals 36. Excellent. So I used my perimeter that they gave us. I added up all of the sides. I saw that I had two different variables here, h and x. I said, you know what? Let me find out what h is in terms of x. I got it. Then I found I had length, width, and height. And I said, you know what? I want my own volume formula. So let's do it. Length, width, and height. I simplified it, and I got volume equals 36x squared minus 6x cubed. I said, hey, that reminds me exactly what they gave me up here, except I have my A, which is 36. Let's see what they want us to do for part B. Part B says find the value of x that makes the volume a maximum. That makes the volume a maximum. When you are looking to maximize, you must please think derivative. So we are going to have to take the derivative of this volume because that's what they want you to maximize is the volume. So for part B, I need to take the derivative of 36x squared minus 6x cubed. So I am going to do that, dv over dx, that is the derivative. And when we do the derivative, what we do is we take this exponent and multiply it by the coefficient. So 36 times 2 is 72. Once we multiply it, we then have to subtract 1. I like to say it kind of lost a life because you used it here, so it just kind of lost an exponent life. So this is 2 minus 1, which is just x. Okay, let's do the same thing here. Take the exponent 3, multiply it by the coefficient in front, negative 6. I'm at negative 18. Now it lost 1 because you used it, so 3 minus 1 is 18. Negative 18x squared. Now that I took the derivative, what I can do is I can set this equal to 0 because I need to find what the x is because it says find the value of x. So now I'm going to say, okay, 0 equals 72x minus 18x squared. I cannot do anything with this because I have this minus. I must turn this back into a multiplication problem, and how you do that is you factor. Factoring means you divide out a common number and or variable. I see that I can divide out an 18 because 72 can be divided by 18. And I also can take out an x to the first because this has an x to the first to give. So let's do that. Dividing this out, I get 72 divided by 18 is going to give me 4. X to the first divided by x to the first is x to the 0, so it's just 4. Negative 18 divided by 18 is negative 1. X squared divided by x first is just x. 2 minus 1 is just 1. So now that I have a multiplication problem here, what I'm able to do, and I'm just going to do right here, I don't need a big space, is use what's called the zero product property. That's where we split these and set them both equal to 0. So my 18x equals 0. Well, that doesn't really help because x is 0 if we divide. All right. If the length was 0, or actually if the width was 0, then we wouldn't have a cuboid. So that doesn't help us. Let's do the next one. 4 minus x equals 0. I can subtract 4 from both sides. I get negative x equals negative 4. This is really a 1, so I'm going out of the box. I write really big. Negative 1 divided by both sides, so x equals 4. So this one I can't use because it's 0. I don't want a side that's 0. This one, yes, I can use. I found to maximize the volume, my x needs to be 4. This is a very lengthy problem. If you'd like to pause, this is a very nice picture to pause at. Please try to follow it along. If you get it, that's excellent. A couple takeaways here. One, remember if you're going to maximize, you're looking to do the derivative. If they give you a total length of edges, that is perimeter, and getting all of your dimensions, length, width, and height into one variable, which we did. So good luck. This has been paper 1, example number 15.